Many people become intimidated when you mention the word algebra, thinking that it is something complex and difficult to understand. But here's the trick. You already know how to do algebra. If you can solve this problem, blank plus 7 equals 9, then you know how to do algebra. Algebra at its core is just a matter of filling in the blank. Let's look at other examples. 9 times something equals 36. We all know this answer is 4. 17 minus something gives us 9. With a little bit of thought, we can figure out the answer is 8. And how about something divided by 5 equals 9? Maybe it comes to you immediately, maybe it takes a moment, but I'm sure you figured out the answer was 45. We've been doing problems like this since we learned how to do basic arithmetic, and if we can solve problems of this type, we can learn the basics of algebra. 5 plus something equals 8. Every single one of us knows the answer is 3. To turn this into algebra, we need to replace the blank with a variable. How about 5 plus x equals 8? It's the same problem as this. We would just answer x equals 3 instead of filling in the blank. That's it. That's the basics of algebra. You already know how to do it. Let's talk about that term variable. A variable is a symbol, usually a letter from the English alphabet, which represents an unknown number, a letter that acts as the blank to be filled in. For example, n plus 7 equals 15. You might also read this as 7 more than n is 15. With subtraction, you might say 7 less than y equals 1. Multiplication, notice that there's no symbol between the 7 and the b. You just sort of smash them together. A dot, or an x, that we would normally want to see for multiplication is implied. So if you see a number and a variable smashed together, that means multiplication. You might read this one as 7 multiplied by b is 56. And division, note that we're using the slash instead of the line and 2 dots symbol. More often than not going forward, we're going to use a slash in between two values to indicate division. So this set of symbols means c divided by 7 is 9. I'm going to guess that you got all 3 of these correct without even having to do that much work on it. Y must be 8 up here. 8 minus 7 is 1. B is also worth 8. 7 times 8 is 56. And what divides by 7 to get 9? Well, C must be worth 63. All of the problems we've shown you so far are equations. Equations are a mathematical statement, a mathematical sentence that defines two things as being equal to each other. If we have n plus 2 equals 13, we're saying that n plus 2 and 13 have the same value. They represent the same amount. That is what allows us to determine that n, in this case, must be worth 11, because both sides of the equal sign have to come out to the same value. 2 plus 2 equals 4 is an equation. 2 plus 2 and 4 represent the same amount. That's what the equal sign means. 10 is greater than 7 is not an equation. Now, there is an element of algebra that we can do when we're talking about less than and greater than signs, but we're not going to get to that yet. For now, what we're looking for is an equal sign. If there is an equal sign, it's a solvable problem. If there's no equal sign, we can't solve it using algebra. 3y plus 2 equals 14. 3y plus 2 and 14 represent the same amount. That's what's going to allow us to figure out what y is worth. 4x plus 11, well, that's it. There's no way we can solve this because there's no equals sign. By the end of this unit, we'll be doing big, complicated problems like x divided by 2 equals the quantity x minus 10 all plus 4, and that's solvable. We can figure out what x is worth because there is an equal sign. Quantity subquantity 3a plus 9 minus c, n subquantity plus 7, n quantity divided by 10, it looks complicated, but ultimately we can't solve it. We can't figure out what a and z are worth because we don't know what that expression is equal to. There's no equal sign. Everything on the left is solvable because there's an equal sign. Things on the right, not solvable. Nothing we can do. Okay, the next slide is possibly the most important slide you're going to see in this entire unit, maybe this entire semester. The rules of algebra. Rule number 1, the variable wants to be alone. Usually, we're going to have problems where our variable is attached to some sort of mathematical action. We want to get rid of that mathematical action so the variable can be by itself. Number 2, use opposite math to remove things. Those mathematical actions we want to get rid of so the variable can be alone. To get rid of them, to blow them up, we're going to use opposite math. Addition and subtraction are opposites, multiplication and division are opposites, and roots and exponents are opposites, though we won't start using those for a couple of weeks. Finally, what happens on one side of the equal sign must happen on the other side too. You can't just take away 3 or multiply by 5 on one side of an equation. Whatever you do on one side, you have to do to the other. There is a fourth rule that's coming soon. We don't need to worry about it yet. All right, let's look at an example. X plus 3 equals 5. Now, I am positive every single one of you, without having to even think about it, recognized immediately that the x in this case has to be worth 2, because 2 plus 3 equals 5. But let's go through our rules of algebra and see why they work for this simple problem. Rule number 1, the variable wants to be alone. I'm going to write the letter x down here by itself, equals, and then leave this side blank. When I say the variable wants to be alone, what I mean is that there should be nothing in between the variable and the equal sign. All this space is free and empty. In order to accomplish that, we have to get rid of the plus 3. Because right now, the x is attached to that plus 3. We want the x to be unattached, all by itself. That means we have to get rid of this. How do we get rid of it? How do we remove it? Rule number 2, we use opposite math. The opposite of plus 3 is minus 3. Addition and subtraction are opposites. But don't forget rule number 3. What happens on one side must happen on the other side too. If we subtract 3 from the left side of the equal sign, we also have to subtract 3 from the other side of the equal sign. Otherwise, things fall out of balance. All right, now let's see what happens. Nothing changes for the x. It drops straight down. Plus 3 minus 3 gives us a 0. They are opposites. They cancel each other out. So let's cross them out. They no longer exist. The equal sign comes straight down. And then we have 5 minus 3, which of course is 2, which is exactly what we thought x would be worth, because x being 2 means 2 plus 3 equals 5. By saying that x is equal to 2, we are saying that these two things, x and 2, are the same, and they can replace each other. That means to check our work, we can go back to the original problem and replace the letter x with a 2. If the math then works out, we've done our algebra correctly. 2 plus 3 equals 5. How about another example, this time with subtraction? All right, rule number 1, the variable wants to be alone. Now our variable is j. Let's write it down here, all by itself, nothing in between it and the equal sign. Step 2, what is currently attached to that j, and how do we get rid of it? Right now, the thing preventing the j from being alone is this minus 31. How do we get rid of minus 31? Rule number 2 says we use opposite math. The opposite of minus 31 is plus 31. But remember, what happens on one side has to happen on the other side too. So let's add 31 on the right side as well. Now we see what happens. The j comes down unchanged. Minus 31 plus 31 are opposites, so we cross them out. They blow each other up. The equal sign always comes straight down without changing. And then we do 17 plus 31, which is 48. We've now established that the variable j is the same as the number 48. They're equal, which means that to check our work, we can replace the letter j with the number 48 in the original problem. 48 minus 31 does equal 17. We've done our algebra correctly. What about multiplication? 9y equals 54. Remember, if you smash a number and a variable together, that implies multiplication. There's an invisible dot in between those. So, rule 1. We want to get the variable by itself. That means the y needs to be by itself with nothing between it and the equal sign. What do we need to do to make that happen? Well, right now, this y is attached to this times 9. So we need to get rid of the times 9. How do we get rid of times 9? Well, what's the opposite of multiplying? Dividing. Notice we're using a fraction like bar to indicate division. That's going to become the standard practice the farther into your math education you get. Rule number 3, whatever we do on the left side, we have to do on the right side. So we also have to divide by 9 over here. All right, let's see what happens. Times 9 divided by 9, those are opposites. They cancel each other out. The y is now free to be by itself. The equal sign comes down. 54 divided by 9 is 6. We have now established that y is equal to 6. Y and 6 are the same thing. We can check our work by replacing the letter y with the number 6 in the original problem. 9 times 6 does equal 54. So our math is correct. One last example, this time division. T divided by 6 equals 7. Yes, I know in the previous slide I said that we would be using the slash mark for division, but I decided to use the old school division mark here just for clarity. So we're trying to ask what number divided by 6 gives us 7. Okay, rule number 1. The variable wants to be by itself. T. Nothing in between it and the equal sign. Number 2. What is stopping it from being by itself, and how do we get rid of it? Right now, we are attached to a divided by 6. We use opposite math to get rid of this. What's the opposite of divided by 6? Times 6. Rule number 3, what happens on one side has to happen on the other side. We multiplied by 6 on the left, you have to multiply by 6 on the right. Okay, let's see what happens. T comes down. Divided by 6 times 6, that's opposite math. It blows up. Equal sign comes down. 7 times 6 is 42. So our answer is that t is worth 42. Let's check our work. Replace the t with the number 42 in the original problem and see if it works. 42 divided by 6 is 7. Our algebra is correct. In the homework folder of OneNote, you will see a short assignment called Intro to Algebra Worksheet. That is due by class tomorrow. If you have any questions, please log into my office hours this afternoon, and I will see you in the morning. Goodbye.